Welcome back to part 2 of mole calculations. Here's our next question. I need 3 moles of water for this reaction. How many grams will I need? I've been given the number of moles. I am being asked for the number of grams, which is a mass, which is unknown right now. And they've told me the molecule in question, so that's asking me for molecular mass. Now this is molecular mass. And we give it the subscript R because we are doing the calculation using relative atomic mass units. So all the relative atomic masses, which are on the bottom of every element on this table, this is what we use to add up all the elements within our molecule. So if I've got 2 hydrogens, well, I'll need to double this number. If I've got 1 oxygen, I'll just need one of those, and I add the whole total together. Now, molecular mass here is measured in atomic mass units. In your textbook, you may have found that when it does this, it doesn't have the unit at all, it just has a number. This is actually atomic mass units, and they are defined as one of carbon-12's protons or one of carbon-12's neutrons. So we convert this into molar mass, which is just capital M. So we're no longer dealing with atomic mass units now. We are using grams per mole because we've scaled this up to 1 mole. Now we can just throw all these values into an equation we've seen before, which is molar mass is equal to the mass divided by number of moles. Well, we are trying to solve for m, the mass, so let's rearrange our equation. Now we can put in our values. Our units cancel. And we get a result of 54.0444 grams of water. Even though we calculated a mass for this question here, how many grams will I need? Well, that's assuming that for every equation that you've been given, you have to use that certain number of moles that's written in the front. But this is not true. We actually use this more often as a ratio of combinations, ratio of our reactants versus our products. So more realistically, you might have something like, well, I have 100 grams of water. How many grams of magnesium nitride will I need? Now, from our example before, I mentioned that we don't always use the mole in front of the molecule here to measure out the amounts we need for our reaction. We often have, say, 100 grams of water, and we need to calculate how much do we need of the other stuff to complete our reaction. So in this example, if I have 100 grams of water, how much magnesium nitride will I need? Well, the first thing I'll need to do is I'll need to find out how many moles is this. So our equation will be, we know the mass, we don't know the number of moles, and we can calculate the molar mass, which we have already done before. It ended up being 18.0148. Solve for n. Okay, now that we've found out how many moles there are of water in 100 grams, we now can find out how much magnesium nitride we'll need. If the ratio here is 3:1, 3 molecules of water reacts with 1 molecule of magnesium nitride, then we need to somehow quantify this mole here and equate it to the value of 3 molecules. Now I'm sure there is a nicer equation of doing this, but for now what I'll use is I'll just say, let's pretend this number of moles is equal to 3 units of that. And then if we can divide that by 3 and find how much 1 unit is worth, we'll find out equivalent unit of that. And we get a result of 1 unit is worth 1.85 moles, which is equivalent to the number of moles of magnesium nitride. But we need to measure this stuff, so we need to find out how much this stuff weighs if I have 1.85 moles of it. Well, I would need to multiply this by its molecular mass. So the molecular mass is equal to the sum of all the relative atomic mass units of the elements Now that I've found the molar mass of magnesium nitride, I can then throw it into the same equation as this to calculate how much mass we need. We get a result of 186.71 grams of magnesium nitride. Done.